All right, so I'll use problem 2 as a backdrop for this. Very similar. You might have 4 groups, you might have 3 groups. You'll be given scores for each of the groups, very similar to how it's set up here. In this case, we have attractiveness of logos. They're all were shown. In this case, the group difference here is the actual university itself. So everybody evaluated a logo and gave it a score. And so the grouping variable here is the university. Okay. So we need, for these ANOVA problems, we need one column for the group and we need one column for the evaluation. And as I mentioned in class, this is what you don't want to do is you don't want to do, one sec, I think my VPN kicked me out here. Nope, am I still on? Yeah, I'm still on. Okay. So I'm in variable view right now. What you don't want to do is something like this. Right? The group should all be in one variable. So what you want to be doing is creating a grouping variable and then we'll just call it DV here for the sake of that. All right, the outcome variable, the downstream effect. I just like to label it so that's already labeled when I look at it. And then in this case, I'm gonna pop this on my other screen here. I have 3 groups. I have XU. I have UC, and it's nice to label, not because you can't remember it, but when you run the outputs, it'll all be there for you. And then OSU. Okay. Oopsies, I put that in the wrong one. Okay, copy and paste that. Okay. I just copy and paste that. Okay. All right, and then we want to change these. Usually you need to change them to scale to run. I think I saw a few instances where it worked, but typically if it's not running, that's the issue. All right, so in a ANOVA problem, you're going to have 2 types of variables, a group variable and your outcome variable. That's it. You're not going to have a variable for each group. That's the common mistake on the exam if you make a mistake on this question, okay? And at this point now, right, we're going to go ahead and call the XU. We already gave them the values that we have from the homework problem 1, 2, 3, 4. Let's see, I'll show you guys this. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 people per group. So I'm just going to go ahead and get the group ones in first and label these ones. These are 2s for the other school, and then these are my 3s. And again, this is, if you're following the recording, this is problem set 1, problem 1. All right, and then I'm going to enter the values 1, 3, 3, 4, 5, 2, 1, 3, 4, 2, 2, 3, 3, 1, 4, 5, 3, 2, 1, and then 5, 5, 4, 4, 6, 7, 6, oops, 6, 5, 4, 7. 4, 7. I think I entered this one wrong. 5, 5, 4, 4, 6, 7, 6, 5, 4, 7. Okay, so that's right. All right, hopefully I entered the data right. If there's any mistakes from differences from your homework, you can just blame my data entry, but at least the steps will be consistent. All right, so I've got this in. I'm going to go ahead and run my, making sure I did not take points off on this on the homework, but you don't want to compare means on one-way ANOVA now, right? I guess technically you could. I just prefer to go to general linear model because I can graph things as well. So GLM, univariate, and this test runs everything. That's why I prefer to go, why I teach this one per se versus the other one. Your DV obviously goes into DV, and then your group variable will go into fixed factor. You're going to go ahead and create a plot to be able to see and make the interpretation easier for you. You don't have to, but it makes a lot of things easier. And then I'm going to go ahead and run my scripts under options, and I'm going to hit OK. And again, this test is the omnibus test because I have 3 groups. If I only had 2 groups, like problem set 1, number 2, I could then just make the interpretation after this test because there's only 2 means. In this case, I have 3 means. And we can already tell from you when you did the homework that OSU is probably going to be different from both XU and UC, given the differences in the means, at least a 2-point difference here, almost a 2-point difference, a little over actually. So we're probably going to have a Tukey test that suggests OSU is greater than XU and OSU is greater than UC. They don't believe UC and XU are different statistically speaking, but you never know, so it's worth running the test. And again, you can do this all in one step if you want. I'm going to go back to the general linear model univariate, and then I'm going to go ahead and hit post hoc. Bring over the group variable, and again, your Tukey is the one we typically run. The controls the most conservative in terms of minimizing type 1 errors, and I'll hit OK. It's going to run everything again, and here what I'm looking for is the actual post hoc table. And remember, there's not. Remember that the first column here is the reference group. Again, we noticed that OSU happened to be bigger than XU and UC, so we can just go ahead and look at that one first. And to our what we expected, we definitely have results that suggest what we saw in the plot, that OSU, again, look at the means, 5.3 is greater, statistically greater than the 3 of Xavier and greater than the 2.6 of UC. Okay. And then we can also look at XU and UC. We kind of expected that to not be significantly different, and that is correct. It's over that 0.05. Okay. Questions on that? Again,
is 0.05 what we're going to go with on the exam? I know this, like, we can use 0.05 or 0.1. I'm not sure if that's going to be specifically said.
It's going to be one of the two. I can't remember which is one. There might be a mix. Just depends on the data set. But I'll make that clear, and I'll remind everyone on the exam. I'll be honest with you. I won't ever take. I mean, if that's the only issue, if someone were to, let's say for instance, I said 0.1 and you made the interpretation of 0.5, I am not going to take a point off on that. Okay, so don't worry too much about that. So I'm more concerned with running the outputs, understanding what it's saying.
Thank you.
Yep. Questions on, to me, again, I'm going to go back to making sure this is the important piece right here when you're setting it up and understanding what this means here, right? These different groups. Again, you don't want to create columns. They should all the values, all the DV, the outcome variable, whatever it is, needs to be in one column, the scores, right? So when you see the test, right, we're not creating 3 columns of scores here. This group definition is one variable, and the scores is another column of variables. Okay, so it should be 2 columns. Questions on that? Okay, let's work through the first problem on problem set 2. In this situation, we have three variables. We have a reported downstream outcome effect EV of purchase intention, and we want to know essentially how brand engagement and brand schemacity, two dispositions, two independent variables, do they differentially impact purchase intention? Is one more significant, or excuse me, is one statistically significant, one's not? Are they both? What does that relationship look like? In this case, we don't have groups. We don't have groups. Okay. And so there's no reference to any groups whatsoever, right? You're gonna see questions like relationship. You're gonna see questions such as correlation, influence, right? It's not, and the reason why this is a huge, I guess, trigger or hint is because it's not causation. Whereas, hey, these different groups differentially impact, in the last problem that we talked about, that's causation. In this case, it's more relationship driven. So correlations, regressions, influence, relationships. You won't see anything about groups. You won't see anything about differences, anything about causation, you know, things of that nature. Okay. Um, so everybody evaluated the extent to which they carried the disposition of brand engagement. Everyone evaluated the extent self-reported their brand schemacity, and everybody reported their purchase intentions in a survey type instrument. Okay. And so let's go ahead and enter that data. So we have three variables. We don't have any groups. I'm gonna just go ahead and start a new data set here. Oopsies. Got brand engagement, brand schemacity, and purchase intention. Okay, let me go ahead and label this as well. And go ahead and change that. Okay. And then I'll enter 6, 4, 4, 5, 5, 4, 3, 3, 6, 2, 4, 2, whoopsies, 2, 3. Oops, I messed that up. 2, 4, 2, 3, 1. It's 5, 5, 3, 4, 3, 5, 3. Okay. All right. And so I'm going to go ahead and run correlations. I'm going to go one at a time just to kind of emphasize what's happening here. Let me kind of go back to the problem set here. So what I've got here now is I want to understand the relationship between brand engagement and purchase intention. Then I want to understand the relationship between brand schematics and purchase intention. So I'm looking for correlations here. Okay. Once I run those correlations, then I can determine which one is the one that we should focus on going forward. A couple ways this is going to that you can make that determination is through statistical significance. If there's no relationship with one and a significant relationship with the other, that's obvious that we're going to move on with that variable. It could be that both of them are statistically significant. In that case, I'll look at the actual value, the actual degree of the relationship, and go with the one that's larger. Maybe one's positive, one's negative, and then I have to make kind of more of a determination of which makes the most sense from a marketing or just a business standpoint. It's likely on the exam you'll face either a situation where they're one's significant, one's not, or both are significant, and you'll decide which one based on degree is the one that you're going to focus on. Okay, so I won't go and make you start guessing that one's a positive relation, one's a negative, inversely related. I'm not going to mess with that on the exam. Okay, so let's do that piece first. Run our correlations. I'll just go ahead and run each one separate just to kind of make sure we're on the same page. So I'll go ahead and go brand engagement, purchase intention, and then I'll just go ahead and run the other one now, and then we can analyze it together real quick or look at it. And then So we have here is brand engagement and purchase intention was not statistically significant. It was, we said it at 0.10 is a cutoff, well above the 0.10, but brand schemacity and purchase intention, it was below 0.10. So we're going to focus in on this relationship, the brand schemacity and purchase intention for the regression equation. So in this case, for part C on the homework, we would move on with the brand schemacity as the actual personality disposition we're going to be focusing on more, because there is a relationship between that and purchase intention. In the case of understanding how these are set up, brand schemacity is this idea that people tend to focus more on the actual product features as opposed to the brand name. So people who are higher in brand schemacity certainly care more about, like, again, this is vacuums. I'm not a vacuum expert, but suction power. They care more about lights on the vacuum, the color, I mean, how much dirt it can carry. I have no idea what a vacuum is evaluated on, so I'm just making this completely up. But anyways, so in this case, as a marketer, I'm going to be more focused in on providing features for my customers, right? Generally speaking. So that's how I would go about with C. Now, for homework, for an exam, if you say, hey, we're focusing more on brand schemacity because it's a statistical significant relationship and brand engagement was not, you're good. You're golden on that. Okay. But understanding beyond that in terms of what that means for decision making for strategic purposes is certainly an important piece as well too. But again, that's something you're going to be you've done in your course projects. So for the exam, I just want to make sure you can run it. So now we're going to go ahead and run the regression equation, right? So as a quick reminder, we decided in 1C we're going to focus on brand schemacity because it was a statistical significant correlation. So now I'm going to want to know with brand schemacity, if a person scores 4 on that personality disposition, what is the predicted purchase intention? So I'm going to go ahead and run a regression now. My data. And go to analyze, regression, go to linear. Again, if you throw in brand engagement in a model, it's totally fine. In this case for the class, I would we can keep it cleaner. Just go ahead and throw in purchase intention in the DV and brand schemacity IV. Don't have to do anything over here, okay? And then we got a regression equation here, right? And so we need a couple of pieces here. We need the actual y-intercept and the slope, right? So our y-intercept is this constant and our slope is 0.438. And so again, if we go back into, and again, I'm gonna have to type this out, I'm sorry. It's gonna take me a second here. And you can handwrite this on the exam. Again, the regression equation is essentially your DV, right, equals your y-intercept, B of O plus your slope, B1x, plus your error term. And the error term is actually any unexplained variance, but we're going to kick that out right now. So then we're going to go ahead and go y equals, in this case, y is actual purchase intention, right? And then our slope from our output, excuse me, slope, our y-intercept is 2.688. I don't care if it's significant or not. You're going to include that in the equation because that is where the actual the line crosses the y-axis. Okay, so we need that for the model. It's 2.688 plus our slope, B1, times our independent variable of percent disposition. Okay, so you don't have to write all these steps when you do the exam. I'm just doing it to make it clear. So now I need B1, which is that 0.438. And it is significant at the 0.1 level, but at this point, you're just going to enter it no matter what. Oops. 0.478, I think what it was. I already forgot. It's been a long day. Not because of you guys, just a bunch of meetings today. And then I've got my equation now. Purchase intention is a function of the y-intercept of 2.688 plus my IV, and the coefficient or slope is 0.478, right? So I'm asking now on the problem for what is the purchase intention if a person scores 4 on that personality disposition that we're focusing on. So now I can take this equation, and again, you don't have to write all these steps on the exam. Just fill that in, and that gets me, I had graded this 22 times, a little bit less than that. I think it was 4.44. Is that memory serves me right? Is that correct? So I'll just run it just in case, just for making sure we're all on the same page. So 0.478 times 4 plus 2.688. 4.6. Okay, whatever. 4. I don't know why I was thinking 4.44, but 4.6. So somewhere around there. Rounding, things of that nature, I'm not too worried about. Okay. Questions on that? So you have a problem similar to that.
I think it should have been multiplied by 0.438.
See that again? Oh, 4.3. Is that where the difference was?
Multiplied by 0.438.
Yeah, I had that wrong.
Yes.
All right, so that should get me to 4.44, right? I typed it in wrong. There you go. I remember the 4.44 I was grading. Like I said, when you grade enough times, it kind of sticks with you. So, all right. Questions? All right. So, I mean, so far, I feel like you're good. All of you are acing this exam, which is good for me. I mean, I want you guys to do well on this. So, but any questions at all about this problem or these types of problems? Okay. Let's go to the simple slope problem. All right, so I have, per the problem, you can go back to the problem set directions if you're rewatching this video. I've got 3 variables here. I've got CFC, I've got compulsive buying tendencies, and I've got debt. As I identified in the problem, debt is your DV, your outcome measure. And essentially what we're looking at, broadly speaking, is the function of debt as a byproduct of both compulsive buying tendencies and CFC. To bypass all of this, right, we made it a little bit easier, saying that, okay, compulsive buying tendency has a direct effect, a direct relationship influence on debt, right? So the more that somebody has compulsive buying tendencies, it's likely we can predict that they're probably going to have higher debt of any sort, okay? And how that might vary, right? That relationship might vary as a function or a moderator of consideration of future consequences. So somebody who thinks more about the future as opposed to the present day might likely have less debt. So in other words, high CFC people, right, when considering both compulsive buying tendencies and debt, will probably have lower debt overall compared to people who have low CFC as a moderate. So essentially, high CFC is really going to minimize the amount of debt as a function of compulsive buying tendencies compared to low CFC. Okay, so that's essentially what we're looking at. Again, on the exam, I will identify what the DV is. In this case, the DV is debt. The main IV is compulsive buying tendencies, and CFC is going to be the moderator in this case. Again, I will identify that. This problem was a little bit different than the final exam problem because here you have 2 independent variables essentially that are continuous in nature. Okay, so you had to mean deviate both of these. On the exam, comp by will be what we call more of a dummy coded variable, and it will be essentially two groups, right? It'll be, and I'm not going to tell you now what it is, but one will be, condition one, and sorry, it'll be coded 0, and the other condition will be coded 2. Okay. That will be labeled for you. You won't have to label it. Okay, that's going to be done for you. So in this case, you'll have a continuous moderator on the exam, such as the homework problem that you had. And for the exam, you'll have a dummy coded variable. We did this problem in class, so you can go back to that recording the day we talked about regression. It's in Canvas, and I walk through this process, right? So the difference is actually easier, in my humble opinion, because you don't have to mean deviate the dummy coded variable. Okay. So you only have to mean deviate the moderator for the exam. All right. So that will be the only difference there, is you won't have to mean deviate the dummy coded variable. It's categorical nature. It's 0, 1. There's not really any reason to, because it's easy to interpret. The whole idea why we mean deviate is because it makes the interpretation much more obvious and easy when you look at the coefficients on the regression model. And in the case of 1 or 2 variables, not a big deal. But for a lot of you, you're going to be modeling with much more than 1 to 2 variables. And so when you have a string of variables in a model, it's nice to be able to interpret all of the coefficients essentially from the same vantage point, right? Okay. So let's go ahead and start this process. I need to go ahead and do, oops. Oh, something else. Okay. I don't need to mean deviate det, so I just need to run descriptives on the 2 IVs, analyze descriptive stats, and then I'm going to pull over compulsive buying tendency CFC. All right, so those are my means there. I'm going to pull this aside for a sec so I can kind of use my other screen, but I'll go ahead and run the mean deviated variables. Let's go ahead and go to compute variable. And then I'm going to go ahead and do comp by, let's go MD, mean deviating, call whatever you want. I'm going to throw that variable, and I'm going to subtract the mean, which is 4 or 2.2934. And then I'm going to mean deviate also, transform compute, CFC. Minus the mean for that was 4.7309. Okay. So I've got those 2 new variables. I'm going to go ahead and create the interaction, because not only are we going to interpret the main effects, I need the interaction for the 2 as well. Oh shoot, I skipped the total step, but let me go ahead and create this step first. This will be for the regression model. So I need to create the interaction between the 2. So I'm going to go comp by mean deviated times CFC. Okay, so that gives me interaction. So I have everything I need for the main regression model. I skipped a step from the homework problem, so that I'll come back to here. My apologies for that. Let me just go ahead and copy these over to. So that sets me up for step. I jumped ahead a little bit here. This sets up for what I just did, sets us up for sets us up. So I have the variables now for part C here. Okay. So if you're following this recording, that's what I just did. I skipped this piece that I'll go back here. The reason why I do those mean splits is because I want to be able to see and analyze the data real quick to see what's happening. It's much harder to draw graphs from just the regression model. So doing the ANOVA is easy, makes it a little bit easier. That's just something I like to do. So let's go ahead and create my mean splits for those two variables. You won't have to mean split for the exam, the dummy coded variable. You'll only mean split the moderator that's going to be continuous. So I will need, again, my means. And I'm going to go ahead and go compute. Actually, transform, sorry. Recode into a different variable. I go ahead and address compulsive bind tendency first. Comp. Split. Essentially, we're going to go ahead and go 0 through 2.2934 will be coded -1, and all else will be coded 1. We'll do the same thing for CFC. And then we'll do 0 up to the mean. And then that'll be -1. And all other values will be 1. Okay, so now I've got my mean split. Again, right now I'm working on, just as a quick reminder, where am I at? I created my mean splits, and now I'm going to basically run the ANOVA, and then I can explain the graph. So that's A and B is what I'm doing right now. So let's go ahead and run the ANOVA on that. Analyze general linear model univariate. My DV is credit card debt, and my fixed factors are going to be my comp by and CFC. I'm going to go ahead and set my plots up because I want to be able to see that graph. My main effect essentially is comp by. My moderator CFC, that will be separate lines. I'm going to add that. I don't really care about, I mean, you can do it. We don't really need that right now. I'm just asking us to interpret graphs, but you could run your descripts if you want. Hit OK, and this is the graph you probably got. I remember seeing this. Whoopsies, somebody. And don't worry about significance on the ANOVA. But that's probably a graph that you got, as I probably looks familiar. What it tells us right now is essentially that overall, that lower, right? If you look at the blue slope versus the green slope, the blue is the low CFC. Overall, they have more debt than people who are higher CFC. And that the highest point of debt happens to be people who are higher in compulsive buying tendencies and pretty low in terms of their CFC, right? So that's the highest point there. Low CFC, high compulsive buying tendencies, right? Leads to the most debt. Either way, what we see here is that greater debt for those with compulsive buying tendencies at a higher rate for people with lower CFC. There's a lot of different ways you can interpret it. It depends on how you want to tell the story. You can look at it from this standpoint. You can look at it from this, looking at the slope of the low. You can look at the mean endpoints. You can compare the two. You can look at it from column. A lot of different ways to interpret that, okay? So just keep that in mind. For the exam, it'll be a lot more straightforward. Probably one will be flat and one will have a slope, okay? So it'll be crystal clear how to interpret that. Essentially, with a slope that's essentially parallel to the x-axis, there's no differences, right? There's nothing happening. You'll be focusing more on your interpretation of the slope that's got differences across the different conditions. Okay. that make sense? Okay. All right, now I'm going to go ahead and run my main regression model. I'm going to go to analyze, regression, linear. I already created those variables earlier. So again, credit card debt will go in my dependent variable. CFC will go, let's go ahead and put my main effect here. My comp by mean deviated and my CFC mean deviated in step 1. And then the interaction that I created between the mean deviated variables will go in step 2. Okay. And I know that was a little over to 0.1, but we're just going to go ahead and call that significant at this point. It's close enough, right? Close enough for a homework problem. And now we want to dig in deeper. So essentially what happened here is that we have, just like the ANOVA, when you have 3 groups or more, the ANOVA model is a general kind of omnibus test. Same idea here is that, okay, we've got a marginally significant interaction. We want to understand now, whether one of these slopes is in fact significant. Are they both significant? Right. So we want to test the slopes themselves. So we have to run simple slope analyses to better understand that. So I'm going to go ahead and create some new variables to do that. I want to create, essentially, if you go back to the graph, right? What I'm doing here is I'm creating a scenario, a set of variables to test this slope, and I'm creating a set of variables to test this slope, right? So again, with the blue slope here, those are what we call low CFC, and then we want to test the high CFC people as well. So that's essentially the next set of steps that we're doing. Any questions conceptually before I jump into this of what we're trying to accomplish? Which I think will help too, as you run these steps, that you have a sense of what you're testing. Does that make sense?
Question.
Yeah, go ahead.
Why again do we run the ANOVA before the regression in the simple slopes?
So you don't have to technically do that. I do that
Okay.
because I want to show you a way where you can understand a relationship to be
Okay,
able
so
to
it's
know what
just
kind of
to
test.
kind of see the difference, not
Yeah,
necessary. Okay.
yeah. You can run. You can take the we can graph this, but it takes a lot longer to be able to
Okay.
draw a graph. You can't just ask, SPSS or Stata to draw a graph on this. You have
Yeah.
to. It takes a few steps. So for me, I'm just
Okay.
like, I'm not gonna keep running. I want to be able to keep moving with my data because I have so much data. In theory, this is a small data set, not a big deal, but theoretically, you're never going to really have a situation where you're looking at just, you know, 3 variables,
Yeah.
right? You're going to have tons of variables. And so you just don't have all the time in the world. So it's nice to be able to have some methods and tools for heuristics for seeing what's happening. So this is one way of many ways that you can figure out what's happening with your data. And then when you do run the regressions, you know what you're trying to accomplish. Do I want to tell
Okay.
the story here? Do I want to tell the story here? Right? Because the way I'm setting you guys up for the homework problems, we're telling the story at this level here. But I could easily flip the graph. So if I wanted to, I could easily flip this graph. So if, like, for instance, I can add so we were telling the story here at the CFC level. We could also run the test at the comp by level, which this graph doesn't make as much sense, right?
Mm.
But you can flip, but essentially what I've done is I flipped the graph. So now you're looking at these slopes represent these means. So the ANOVA is what I'm trying to teach you guys, is that you can quickly figure out what story you want to tell, because to run all the steps and the models, you don't want to we just don't have time to be able to keep creating all these variables and tests. So the ANOVA is a quick and dirty way to be able to figure out where I want to tell the story. And in this case, the story makes a lot more sense from the CFC standpoint than the compulsive buying tendency standpoint.
Okay. Thank you.
Right. And again, this was a little bit harder, it's not an easy story to tell. The Homer problem, like I said, will probably have one slope that's flat and one that's, there's clear differences across the experimental conditions to interpret. Okay.
Also, on the exam, are we gonna have to make an interaction?
Yes.
Okay.
Yeah, you have to create interaction for sure. Yeah. And typically a regression, you have to. Any regression model, you have to create your own products. So it's a good question.
Okay, thank you.
Okay, so that's essentially what we're doing here now is we're going to create the variables to be able to test this slope, which is low CFC, and creating the variables for this slope, which is high CFC. Okay, so we're going to go ahead and create, again, it's a little bit counterintuitive, like I mentioned in class. Let's work with this low slope. Because we mean deviated, we actually have to add back one standard deviation to the low slope. Okay, I know it's a little bit counterintuitive on that. And we only create those values for the moderator, right? So we're going to go ahead and create low CFC. We'll take the mean deviated value, and I'm going to add back one standard deviation. And one standard deviation was in our output. Back way over here somewhere. Oh, there it is. So I have a standard deviation for CFC of 0.788, 0.78871. I'm adding back for the low, okay? And then I'll go ahead and see if this works a little bit better. I have to create a new interaction term for the simple slope test, right? So I have to create an interaction with come on. Doing that. Wait, did I not create that variable? Yeah, I did create. Okay. So I'm going to create a variable for comp mean deviated times the low CFC. Okay, so oops, times my new low CFC. Okay, that's the new interaction for the simple slope test. It's not exact, but same. I have to create two set of variables for the high slope as well. I'm going to go ahead and create a new high CFC slope. Just essentially CFC mean deviated minus was 0.78871. And then I have to create the new interaction for that, for the high CFC test. So again, I'm going to just reset that. Hopefully I didn't make a mistake here. I know there's a lot of steps here. Okay, so I've got 4 new variables I created. Low CFC slope, the interaction between low CFC and the comp mean deviated, and the new variable of high CFC, and the interaction between high CFC and the comp compulsive bind mean deviated. Okay, and now I can run my simple slope tests. I'm going to go to regression linear, reset that. Credit card debt, your comp by mean deviated variable, your low CFC, and the new interaction. Okay, I'm going to run them both and we'll talk about it here. Then I'm going to run real credit card debt. Again, my comp by mean deviated, my high CFC, and the actual interaction. Okay. All right, you'll notice here, because they're control variables, the interaction is the same here between comp and low. The low CFC as well is the same. But I promise you, it's only because we entered them as control variables. They are different variables, but that's the test to make sure everything was done right. Okay. We interpret the actual slope test at the actual main effect for the simple slope model. So the comp by is our main effect, mean deviated, and that's well below the 0.05. And the comp by for high is, it's marginally significant. Okay. So when we go back to the graph, it makes sense that the low CFC blue slope is at a higher rate of debt, and that the slope for high CFC is flatter. Still significant, marginally significant, but much more highly significant, and therefore the tests make sense. Okay, in this case, you can interpret a lot of different ways. You could have interpreted that high CFC was not significant, essentially no difference in debt across compliance with buying tendencies. Some people focus just on the low. A lot of different ways you can interpret it. I'm not too, but basically, at the bare minimum, you have to be able to say, hey, my slope test suggested that low CFC was significant across compulsive buying tendencies, such that that people with higher compulsive buying tendencies had greater debt at low CFC versus lower compulsive buying tendencies, and that the slope for the high CFC was not significant. So essentially, high CFC people didn't really differ debt across high or low compulsive buying tendencies. Okay. Something along those lines. It'll be a lot more straightforward, for example. I know this was a little bit harder to interpret, not a straightforward story. What I was really getting at is just showing you the other type of condition where you have to deal with two continuous variables. On the exam, you'll have a categorical variable and a continuous variable. Okay. Which is typically most often where this test is run. Okay. Or models run. Okay. All right. Questions at all from the homework and going through that? Question about the final at all? Anything come to mind since we've been talking about it?
On the SPSS questions, we'll run all this, we'll get our output, and then is it like you're going to ask us a question about what the findings are, or like how's that going to go?
Same as the homework. What's your interpretation of what's happening? Yeah.
Okay.
I just want, I'm not expecting you in such a short amount of time to tell the perfect story. I just really want to make sure what I'm looking for an exam is that you can understand what's significant, what's not significant. So that's what I'm mostly looking for at bare minimum.
Okay.
Maybe if you want and have time and feel like, another sentence to describe what that looks like from a strategic level, that's fine. But really, I just need to know what's significant or not. And it should be the way that the test problems are set up. It'll be a lot more straightforward than this particular problem that we had here. This one was a little bit tougher story to tell. So I realized that.
Okay, perfect. Thank you.
Yeah. So the exam, again, about an hour and a half. So like I say, mention 15 minutes for each of the open response type questions. You do not have to write an intro, you don't have to write a conclusion, you don't have to have perfect grammar. You just got to answer the question. I would not allow yourself to work more than 15 minutes per each problem. I mean, if you're spending more than 15 minutes, you're probably writing stuff that's not necessary per se for that type of problem. Okay, so I'm just looking for some key ideas, the main ideas. And then about an hour that I would budget 4 to 3 quantitative problems. I would say the first 2 shouldn't take very long. This one will take a little bit longer, but I think preparing, running through it one more time will get you there. Obviously it took us a little bit longer here because I was kind of walking through and talking through it a little bit more, but I think, it should be plenty of time. So if you get stuck, I just think you just got to move on. You got to maximize your points. It's not worth trying to be perfect on every problem. I think the key thing is to get everything done and use the budgets that I've provided, 20 minutes max for each problem, but hopefully you should make up some ground. It shouldn't take you more than 10 minutes to run the first quant problem to first 2, and then you have plenty of time to do the simple slope analysis for sure, which is probably going to be the most challenging. And so just really, I think the key things is if you're still spending a little bit of time preparing for the exam, just making sure you play back these steps of what we did, the simple slope analysis tests. Okay. One thing at a time, just run it one at a time. And there's still plenty of time before the exam to prepare for this. So those of you, again, some of you can use the homework problem that you did too as well. Bring that along, build that into your notes as well too for simple slope analysis. So other questions for the quant problems or the final or the exam? I mean, I guess it's not really a final, it's an exam. Okay, I'm gonna go ahead and stop the recorder, and then let's talk a little bit about I can't multitask, as you guys know. Here, let me just shut this thing off first. I'll post this into the last